Okay, so welcome everybody. Thank you so much for joining us today. My name is Kara. I am the hostess of this webinar series. Again, thank you for joining us. I know in a lot of places it's morning for you, or it's late in the evening, or it's in the middle of the day, depending on where you're joining us from. So thank you again for giving us an hour of your time. Just a few things before we get started. As Hank is presenting today, if you could use the Q&A panel to ask questions, I can go ahead and start queuing up questions for the live Q&A at the end. If y'all go ahead and start putting them in during the middle of the presentation and not wait until the end, it will actually let us answer some more questions and get the Q&A going a bit quicker. If at any point today you lose audio or you cannot see the slides or you cannot view his desktop when he's sharing and doing demos, please use the chat panel to communicate with me privately, and I will do my best to help you out and get you up and running as quickly as possible. We are recording, so a link to today's recording will be posted on the DevNet, the Programmability with Cisco DevNet series blog. And again, once Hank gets going, I will share that link in the chat window so it's easy for y'all to go and copy and paste. At the end of today's session, you actually have to exit out of the WebEx environment for it to pop up, but there will be a WebEx survey regarding today's webinar. If you could please take just a quick few minutes to fill that out, I would greatly appreciate your feedback. And as always, I am very interested in knowing what topics y'all are interested in for future webinars. So just a quick rundown on the webinar series. If you're joining us today, you're joining us for the 6th session, Program Networking Devices Using Their APIs. If you are unable to join us for the first 5 sessions, don't worry. Again, I'll share that link in the chat window. If you're interested, please go back and view those recordings. The slide decks are also posted on that series blog as well. The next session is titled Before, During, and After a Security Attack, and that session will take place on April 17th. If you've registered for today's session, which if you're in today's session you have, I will be sending up a follow-up email within 24 hours, so tomorrow, and it will actually have direct registration links for the last 3 sessions in April, May, and June. So please go ahead, be sure that you go ahead and register for those sessions now so you don't forget about those sessions, and we hope to see you on April 17th. So really quickly, I wanted to talk about the raffle and the certificate of participation before we went going. So if this is not your first time to join a DevNet session, you've heard this, but we will be doing a raffle at the end of the series. So the last session of this series is going to be hosted on June 5th. It will take a few weeks to go through the attendance and recording reports, but after that, we will be raffling off Amazon gift cards. We'll be doing a total of 15 gift cards. So please make sure you understand not everyone who attends the series is going to get a gift card. Again, it's going to be a raffle. We're going to be raffling off 15 Amazon gift cards in the amount of $25 US. There will be 10 Amazon gift cards in the amount of 25 to everyone who participates in all of the live sessions. So if you have been able to follow along in this series in all of the live sessions, you're on a great start. Just don't miss the last 3 sessions that are coming up. And then we'll also be raffling off 5 Amazon gift cards for those who have participated in the series, in all sessions of the series, and that can be a combination of watching the recordings or viewing. So if this is your first time to join us, you can still go back and watch the first 5 sessions and be entered in the raffle for those last 5 Amazon gift cards. Certificate of participation, I know a lot of you on the call are always very interested in this. Again, we don't give out certificates of participation for attending single sessions. So although you will not be receiving one just for attending today's session, we will be giving those out again after June 5th, after the last live session has been hosted. During that live session on June 5th, I'll share a link where you can go and sign up for the certificate of participation, and it'll take about a month after that for that certificate to be emailed to you. Again, if anyone has any questions, please chat with me privately in the chat window. And with that, I will go ahead and introduce our speaker today, Hank. If y'all attended the October session, you know Hank, and you probably remember he's got some great interactive slides that he's a little cartoon character. I know all of you are a fan of Hank. But Hank is a developer evangelist with DevNet and focuses his time on demystifying network programmability, net DevOps, and network automation while helping network engineers, both new and experienced, prepare for this new age of networking. Hank proudly holds a CCIE in routing and switching and believes that core networking knowledge and skills are just as important as ever. So with that, welcome again, Hank, and I will pass you the ball and let you go ahead and get started.
Excellent. All right, I am the presenter. And share. All right, we'll do the typical check. Are you seeing my slides okay?
Yes, I can see your slides.
Okay, perfect. And sharing is working successfully. All right, let's jump right in. So as mentioned, today we're going to be covering programming network devices using their APIs. And specifically, we're going to be looking at two standard APIs, which are RESTCONF and NETCONF, available on a variety of CISCO as well as third-party devices that are out there. So these are API platforms that are industry standards that are there. As mentioned, my name is Hank Preston. I've done a handful of the webinars, so hopefully some of you may have stumbled across me before, but if you're interested in following me, I've got all my contact info at the end, and we've got tons of content all over the place covering these types of topics that are out there. So with that, let's go ahead and dive right in. So we're going to be walking through a handful of different pieces today. We're going to start out with kind of an explanation of this concept of model-driven programmability, which is fundamental to the two APIs we're going to be looking at. We're then going to speak briefly about Yang. If you've heard of NetConf before, you've probably heard NetConf coupled together with Yang and phrases like NetConf Yang. And so we'll explain kind of where Yang fits into these APIs. And then we're going to look at first RESTCONF and then NetConf. And I chose that order for today's webinar because RESTCONF, as the name implies, is a REST API. And as like most REST APIs, it's actually quite simple to get started with and understand. So we figured we'd start with that one, and then we move into NetConf, which frankly is probably the one that we'll get to, you'll use more and more often kind of as you go into your pieces that are there. So without further ado, let's jump through into what exactly is model-driven programmability. And so I put together this slide in this kind of a diagram to explain how model-driven programmability and the different standards and protocols that fit into it align to the devices that we talk to. So over on the right, we've got a green box, and that green box represents some network element that's out there. It could be a router, a switch, a firewall, any network device that's out there. And those devices have a series of features: interface configurations, routing protocols, quality of service. And what we want to do is we want to articulate the descriptions of those features, how they're configured, how they're operating in a standard way. And that's where the Yang data models come through. Yang data models are made up of both configuration and operational information, and they could be from standards bodies, or they could be specific to a particular vendor. And we're going to talk a bit more about Yang models in a second as it goes through. What's important to recognize is the Yang models are simply a way to describe the state or the configuration of a device. The way you access that information are through the interfaces that are available at the top of our green box. And so we see NetConf, RESTCONF, and gRPC are listed. NetConf and RESTCONF, as I already mentioned, these are IETF standards, and the RFCs and the dates are listed here. gRPC is an open source project started by Google that also kind of fits into the model-driven programmability space, mostly around streaming telemetry and getting health with the information in the health of your network. We're not going to go into gRPC today, but it is part of the overall model-driven programmability topic. Now, we talked a bit about this Yang and then the transport protocols, but I also think it's good to kind of dive into this. And so if we think about how we communicate over the network with any type of a protocol, we've got two elements that go together with that communication. We have the transport protocol, and then we have the data model that's behind it. Now, every network protocol operates like this, whether it's HTTP, SMTP, FTP. Every way we communicate over the network has these two bits: how we get over the network, so how we address, how we authenticate, how we reach, the ports that are used, addressing. That's part of the transport protocol part of the communication. And then we also have the data that's contained inside of the communication. Now, many protocols like HTTP or SMTP, that single standard describes both the transport across the network as well as how the description of the data looks like once you communicate. With model-driven programmability, for a variety of reasons, these are actually kind of broken up, and what we end up with is the data model, the data part of the communication. That's where the Yang bit fits in. It's the description of what is the data or what we're trying to configure. And then how we access that data can be done over any of these transport protocols that I mentioned. What's key to recognize here is whether we come across with RESTCONF or NETCONF, the data we're accessing and the type of data, the way it's formatted, and how it's laid out is all the same. It's all based on that same Yang standard that's there. Speaking of Yang, let's talk a little bit about it before we jump into the protocols themselves. So Yang is at its heart a modeling language. It's a data model language. If you look at the RFC specification, what you'll find is it's a syntax language so that you can describe things. And you don't have to describe network things with the Yang language. You can describe anything. It is mostly used to describe network pieces that are there. And so let's look at an example of kind of how this fits in and what a data model really is. A data model is nothing more than just an understood and agreed upon way between people or organizations that you're going to describe something. And we use data models every day in our life around the world. And so let's think about the concept of a person, a single person that's out there. So a person has a gender, a person has a height, a weight, hair color, eye color. These are the characteristics that in general everybody on the globe thinks about when you picture a person. And this means that we can very easily describe a person using these characteristics, and everybody will basically understand what you're talking about. And so if I were to describe somebody as a 5'10" male with brown hair and brown eyes, you can immediately start to picture what that person looks like because we all work from the same data model. With Yang, the data models that we're using to describe are things about the network. These could be device-specific details, and so the interfaces on a device, access control lists, VLANs, routing protocol, device-specific. Or these could be data models that are describing kind of a network-wide service. And so you can use Yang to describe how you might want to configure your MPLS VPN service across an entire network rather than specifically on an individual device. Or you could describe system management status across the entire network rather than a specific device. The value here is that as network operators, we can start to use these Yang models to describe the desired state across our network rather than what's more typical where we talk about device-by-device configuration. Now, like many topics, it's beneficial to start kind of at the simpler side, and so our examples today will focus on the device data models and describing an individual device's current state or configuration. Now, where do these models come from? I mentioned early on that models could either be from an industry standard model or they could be vendor specific. And so we have standard models from the groups such as the IETF or OpenConfig that provide vendor agnostic data models that are there. And if a device supports one of these vendor agnostic or these standard data models, then that same data model will work and operate exactly the same way, whether you're working on a CISCO device or a Juniper or some other vendor's device. Now, in a lot of cases, we have features that are supported from one vendor that may differ from another vendor, which is why we also have vendor-specific models. And so from Cisco's perspective, if you're working with a Cisco-specific protocol or a Cisco-specific attribute, then you may need to use a vendor-specific model to access those types of configuration and operational details. What's convenient is that you can support both standard and vendor-specific models on the same device at the exact same time. And so in general, my advice is usually use standard models whenever they're available and only move to the vendor-specific when you have to for one reason or another. If we look at an example of one of these models, in this case, we're looking at the IETF interfaces example. This is a standard model for describing a network interface provided by the IETF. The output display we see on the slide here is from a tool called PyYang. It's a Python library for working with Yang models that are there. I like PyYang because it can let you format these models in a way that's easy to read. So let's walk through what's there. At the top, the first thing we see is the actual module name. So this is the IETF interfaces module. That module is made up of two container objects. Containers, like they sound, contain instances of some repeated attribute. In this case, the repeated attribute would be a list of interfaces. What you'll notice is we've got interfaces container, and then we have an interfaces state container, one for configuration, one for operational or statistical information. Inside of each container, there will be a repeated number of interfaces that are there. And each interface will be keyed off of by the interface name. And this is how we identify one interface uniquely from another. So Gigabit Ethernet 1, Gigabit Ethernet 2, and so on. We then have a series of leafs. Now, leaf is a word inside of the Yang language that is used to describe some attribute or characteristic that's part of the model. And so we can see that I've boxed off the name leaf, but there's also a description, type, enabled. And then if you look underneath interface's state, you'll see physical address, speed, and statistics. The RO or the RW indicates whether these are configuration details, things that you could actually read, write, or change, or whether they're operational bits of information, things that can only be read, read only. And then I believe finally is what we're going to highlight here is this question mark. Question mark indicates an optional field. So if you're sending a configuration to a device for an interface, you don't have to specify the enabled status, but you do have to specify the name as an example. And there's one more on here. And then the data type. Yang is a strongly typed modeling language, which means every single leaf will indicate the exact type of data to be expected. And this is helpful from a development or a programming perspective so that you know what to expect when you retrieve or you send information to a device. So with Yang, that's the basics of Yang. Let's actually put that to work by using the RESTCONF protocol. So RESTCONF is a transport protocol, and it's actually built on top of HTTPS. Like most REST-based APIs, it runs over that same web-style protocol that's there. Now, RESTCONF does only work over HTTPS. It requires it to be a secure protocol transport. And then once you communicate over HTTPS, you've got a series of operations. You can retrieve information, you can update information, and these use the typical REST API verbs of get, post, put, delete. Now, once you've made the communication with the device, you can then communicate either using XML or JSON formatted data. And that's up to you as the developer as you go through. Real quick, more about these operations. When we work with any REST API, oftentimes you'll hear the concept of HTTP CRUD. CRUD stands for create, read, update, and delete. And these are the operations that go along with the HTTP verbs. Those verbs are the methods that you can use as part of the HTTP standard. And so if you want to create something, that would be the C, you would post. That would create an object or create something. To read, that's a GET request. Excuse me. Update would be either put or patch, and then delete is delete as they go through. Now at the end, once we're through with RESTCONF, we'll talk about NETCONF, and you can see here we've got similar operations from NETCONF to take these same actions. Now when you work with RESTCONF, you do have the choice of either XML or JSON-based data. And the way that you determine this when working with the API is through the HTTP headers. If you've worked with any REST API before, you've probably come across headers. Headers are how the HTTP protocol determines the type of data that's being sent back and forth. If you browse a web page with HTTP, the content type would be HTML. If you're working with Yang data across RESTCONF, your content types would be application, Yang data plus JSON or plus XML, depending on what your choice is that you're after. Now, the biggest thing when you're working with any REST API is how you build and construct the URLs or the URIs that are there. And so what we've got here is kind of a legend on how they go through. The first bit is the address of the device you're talking to. In this case, it would typically be the IP address of the network device. And then you'll have the root entry point. That's oftentimes just the word RESTCONF, but you can discover that by actually querying the device at a particular path. If you're interested in data, then you give the data keyword. If you're trying to make an operation, such as save configuration, you would use the operations keyword instead of data there. And then you get into the model, the Yang model information, the module, the container, leaf, and options that go through. This is best seen in an actual example, so let's take a look at an example. Here we've got the URL creation. So again, we start out with HTTPS and then the address for the device, RESTCONF, and then data. Now, if we're targeting that same IETF interfaces model we've looked at before, you can see that first we put in the IETF interfaces, that's the name of the model, then a colon, excuse me, followed by the container that we're after, in this case, interfaces. We're looking for a very particular interface whose name is Gigabit Ethernet 1. And then at the end, you can see in red, we've got depth equals unbounded. That's showing that we can take advantage of different options to manipulate the way the data is returned from RESTCONF as it comes through. Now, after we've gone through some slides, let's actually see this in action. We're going to start out with RESTCONF by using a tool called Postman. Postman is a free, it's a free tool that you can subscribe to that makes working with REST APIs very simple. So what I've got here is I've got a way that I can put in the URL that we're going to go through. And this is that same one we were just looking at, IETF interfaces and then interfaces. You'll see over here I've got host and port. These are variables, and those variables are being substituted inside of the Postman client and taking advantage of one of the DevNet sandboxes that are available completely for free. We've got iosxemanagement.cisco.com. And then the port that it's running on is 9443. RESTCONF will often run on the standard HTTPS port, but in this case, we've seen that we've been able to move it. The other thing that we can notice in here is we've got the username and password, root, and then as it goes through here. Now these usernames and passwords are substituted in underneath this authorization tab, and we can see basic authentication is what we're using for this protocol, and then the username and password are there. Again, these are just variables, showing how we use Postman for any REST API. With those in place, I'll go ahead and hit send on this, and this sends the request off. We can see that the body comes back inside of a JSON format, and here we have the IETF interface's name. We have the interfaces container, which is, again, a list. This square bracket indicates a list. And then we can see details for all the interfaces on the device. Gigabit Ethernet 1, it has a description, IP address, and so on as it goes through. Now I can use a different path. Let's say, again, I wanted not all of the interfaces, but more like this in the slide, we wanted a particular interface. And so here we can see that I've updated the URL, and we've added in interface equals Gigabit Ethernet 1, and I can send this away. When I send this, the body comes back, and it is just the single element for that one interface that was out there. Now, using Postman for working with RESTCONF is a great way to explore the API, but oftentimes what we'll want to do is actually write code, maybe in a language like Python, so that we can automate across our network. So let's look at what these would look like inside of a Python code. Make sure I'm in the right directory. I am. All right. So the first example we're going to look at is this RESTCONF example 1. And so I'm not going to go through the entire Python code that's here. We're going to hit the key elements that are there so that you can see how we're using it. If you're going to take advantage of any REST API using Python, the best library to use is the requests library. It makes sending these requests very simple to go through. So you can see here the key elements. We start out with the headers. Again, I'm going to want JSON data back, so I create a Python dictionary object that specifies my accept header will be application and then yang data plus JSON. I give the base on how we would communicate over RESTCONF. And so, well, again, HTTPS, the IP address and port of my device, RESTCONF and data. And then if I'm interested in a particular interface, the way that we build the URL for that, again, is from the Yang model. So IETF interfaces, that was the container. And then the interface equals, and then I've got a placeholder here. This curly bracket, name curly bracket, is a placeholder where I can substitute in, down here, using the format function in Python, the particular interface name I'm interested in this case, Gigabit Ethernet 1. The next bit is we use the request library to send a GET request. We're trying to read as part of that CRUD operation. So we're going to get the URL that was specified and then providing in the header information that was created, the device's username and password as it goes through, and then we'll print the text back out. So let's run this example over here and see what the data looks like. So Python RESTCONF example1.py. When I run this off, we can see that here, this is the full URL that was sent to. And so it's our device. Again, this is a public sandbox that we've got up in DevNet. And then IETF interfaces, and then it wraps a little bit, but interface equals Gigabit Ethernet 1. And this is the full body of the data that came back, again, in JSON format. The end of my script here is just processing that JSON data and pulling out the particular details, so Gigabit Ethernet 1 and its IP address. Now I have a second version of this demonstration here called 1A. The only difference is rather than looking for Gigabit Ethernet 1, we're looking for loopback 101. So let's try this script. So this one runs. We can see the URL. The only difference is this key value, loopback 101. We get no data back because loopback 101 wasn't found. It doesn't currently exist. So let's see how we could create that using our RESTCONF interface. I'm going to switch to my example 2 here. So a lot of this code will be exactly the same. We're still using requests. In this case, we're adding a new header, content type, which is specifying the type of data that I'm sending to the device. Once again, I'm sending that JSON-based data. The URL looks exactly the same. In fact, it is the same URL. The difference here is that we're going to be sending a put or a post request to this URL to go through. Now the loopback interface details that we want to create are here. So loopback 101, the IP address, the description. We use that data to fully build the body of that we want to send. And so this is a representation of that Yang data in JSON. And you can see I'm substituting in details about the particular interface that I'm interested in. Loopback, its name, its IP address, its net mask. With all of that done, down here we can see where I'm actually sending the put request. So I'm sending a put request instead of the get because we're trying to update, we're trying to create some information that's out there. Providing the headers, the authentication, the body of the data that represents our interface, and we'll send that away and take a look at what we get. And so when I run example 2, oops. You got to do the whole file name. All right, so I run example 2. Once again, remember the URL exactly the same as what we saw with the GET request. This time it's a put request, and the status code comes back as a 201. With REST APIs, any 200 status code typically indicates something went exactly as expected. A 201 specifically is that you created something. When I now rerun that example 1A, remember the first time we ran this, it was interface not found. Now when I run it, we actually get our data back. So I get a block of data that represents that interface for what we created, loopback 101. And here's the information. Now let's say we needed to remove this loopback. It was a temporary loopback and we wanted to pull it away. With RESTCONF, it's as simple as changing from that put request or the get request to retrieve details to a delete request. So my final RESTCONF example code here is here. And what we can see is that the URL, again, is exactly the same. Most of this is the same code. We create our URL, but now instead of request.put or request.get, we're doing a request.delete. The request.delete, we give it the URL. The URL will target a very specific interface that's out there, and then we'll send the delete request. So let's run this one. This is example 3. Run this away. So here, now one thing I want everybody to notice is the URL for the delete is exactly the same as the URL for the get, which was exactly the same as the URL for the put. So whenever we're targeting a resource, in this case our resource is an interface, whether we're trying to retrieve information, update information, or even delete that resource, the URL is always the same. It's the type of HTTP method that determines what you're trying to accomplish. So to update the router, we send a put request. To read information, we sent a get request. And then to delete information, we sent a delete request. We can see our status code is 204. That's different from the 201 when we created the interface. A 204 is still 200. That indicates success. 204 is a delete success message. We can prove that it actually deleted by rerunning that 1A example that tried to retrieve the information. I rerun 1A, and we can see now we got no interface found. The status code for that would actually be a 404 error. You've probably seen 404 errors when you're browsing the web that's out there. So this is a quick look at how we can use RESTCONF to actually communicate with the standard API interface on the device to do all sorts of the basic options that are there. There are data models available on the devices that support interfaces, routing protocols, access control lists, NAT statements, just about anything the device can do. There is a data model that lets you do it over the APIs. All right, let's jump over to, let me jump back to my slides, if I can find them. All right, I'm back to my slides. So let's move from RESTCONF. I'm having some interesting keyboard issues here for a second. Let's jump back and we're going to talk a bit about NETCONF as a protocol instead. So NETCONF is another standard protocol. Remember, we talked about how RESTCONF and NETCONF are both IETF standards. These are transport protocols that we can use across our network to communicate with our device. Now, the NETCONF protocol itself, rather than being built on top of HTTPS like RESTCONF was, it's actually built on top of SSH, the same SSH protocol that we use to communicate with our devices for CLI interfaces. The difference is now instead of sending CLI commands, we're sending NETCONF commands. These NETCONF commands are formatted in XML, and we wrap up our request in what's called a remote procedure call, or an RPC. We then tell it what action we want to take. Rather than the HTTP verbs of get, post, put, and delete, we have the NETCONF operations here, get or get config, edit config. And then the content, whether retrieving or we're sending detail, this content will be contained inside of a data tag, and then it'll be representing the Yang data that's out there. And then as we go forward, what we'll see here now are the operations that are available across our devices. Now we saw different operations that were there inside of the with RESTCONF, where we had get and put and post and delete. With NETCONF, there's an operation set that lets us take different types of actions as well. We can see that we have get and get config. If we're interested in just the configuration parts of the device, we can send a get config. However, if we're also looking for operational details, statistics, counters, the state of the device, the get operation lets us retrieve the state information as well. If we want to change the configuration on the device, and that's whether we're trying to add new configuration, change some configuration, or delete configuration, those all come underneath the edit config operation. And then we can see we also have the ability to copy an entire configuration from one part of the device to another. We can delete parts of a configuration. And then NETCONF also gives us the ability to lock and unlock. And so if we want to make changes to a device and make sure we're the only ones making changes to the device, NETCONF gives us the operation to take those capabilities as well. Now let's look at NETCONF in action, because I think that's really where we'll see be able to see the power and how all these bits and pieces work together. So I'm going to jump back to our code window here, and we're going to get ourselves looking. So like we started before, or like we did with RESTCONF, we're actually going to walk through the same flow, retrieving information about the device, and then we're going to take a look at how we can create and update and edit the configuration. For our first bit, actually before we jump into that, I'm going to show one other example. So we'll pause on this. Now I mentioned how NETCONF runs over the top of SSH. And so you've probably SSH'd to a device. In fact, the device that we're interfacing with is one of our DevNet sandboxes. And so I can SSH to that device, and we can take a look at it. So if I come in here, I'm going to SSH on port 8181, because we've remapped the SSH port. And then the address for this device is ios-xe mgmt.cisco.com. This is the same device that our RESTCONF examples are communicating with. This will prompt me for my password. So D, I'll just put the password in here. So now I've SSH to the device, and we can see I did that using the SSH terminal that's here on port, and now I'm on a CSR device, and I can do, as you'd expect, the typical types of commands that are there. Now NETCONF also runs on SSH, and so what we can actually do is we can talk with our device over with NETCONF using that same type of a piece. So I'm going to paste in a command here. I'm going to make my window a little wider so it doesn't wrap. And so what we're doing is I'm doing SSH, and then I'm turning on a particular host key algorithm that NETCONF under the hood is using. And so the host key algorithm is how we actually do the key verification that's there, and NETCONF is using one that's not enabled by default on my workstation. Same address, right? Root at iosxe.management.cisco.com. In this case, NETCONF we've got remapped to port 10,000. The standard NETCONF port is 830, but again in our sandbox we've had to remap that. And then here we're flagging that we're going to be communicating with the NETCONF subsystem on the device. So again, it's still the same SSH command, we're just passing in the pieces necessary. And so instead of connecting to the iOS CLI application, we're going to connect with NETCONF. Send that away. Ooh, and that's a lot of extra. Hold on a second. I have all sorts of weird keyboard issues going on here at the house today. All right. Let's try that again. Live demos are fantastic. All right. So we send the SSH command off. Once again, it's asking for the password. So type that in. It's the same password in this case because we're using the same AAA authentication. If I type that right, my keyboard dropped off again, so I don't know if I typed it right or not. Let's see. And paste. Come on. That's going to make demos really hard if I can't type. Okay. All right. Password was wrong. Let me get the password again, because gosh knows what I pasted in there. All right. There we go. So password works. So what we've now done is we started and opened up a NETCONF connection to the device, and it sent its hello back. So any type of communication with the device, right? We always have that three-way. Hello one way, we say hello back. The device has sent its NETCONF hello back. And what we can see in here is actually primarily a list of the capabilities of the data models that are supported by this device. Now it's waiting for me to say hello back to it. And we do that by crafting a NETCONF payload and sending it off. Now I'm practicing copy and paste because these payloads are not something I'd want to free type. But right here, this bit that I just pasted in, I'll highlight it. This is the XML body for NETCONF that lets me say hello back. It's quite a simple one as NETCONF payloads go. So I send that back. We've now completed the opening communication with the device. I've been able to say, okay, we've got an open NETCONF session to my device, but it didn't say anything back because, again, this is a programmatic interface. We've just simply said, okay, we're in good shape. Now, this is where we would send off our edit configs or our different types of RPCs. Now, as you can see, this is not the best way to communicate with the device. Handcrafting XML payloads and sending them over SSH is not something I would recommend to anybody. So I'm just going to go ahead and send in a closed session request. And so you can see here I sent this closed session. That was the key part of it. And then the device gave me an RPC reply. So I sent it an RPC. It sent me back an RPC reply. And you'll notice this message ID that kind of links them together. So I put in this one, 1239123, and the reply came back with the same message. And so here we've communicated with NETCONF, but in a very inefficient way. Doing handcrafted SSH connections is not something that we would want to recommend. This is why using libraries and languages like Python is a much better solution. So let's go back to that. So here I've got my Python code that's going to be our first example. Now with Python, when we made RESTCONF requests, we used the requests library. To make NETCONF requests, we're going to use the NC client library. NC client is the NETCONF client for Python. And we can see that I've got a couple of XML libraries that I'm also bringing in to work with that XML data. Now with RESTCONF, we worked with URLs to indicate the type of information we were after. With NETCONF, what we craft are what's called a filter. And so here I've got the body, or kind of a template for a filter, that'll let me communicate and request information about a particular data model. In this case, it's that same IETF interfaces data model. And we can see that I'm going to ask for details on a very particular interface. And I've got that placeholder inside of my code that says I'm going to be interested in a particular interface name. With the template for the filter created, down here, I'm connecting to my device. I'm giving it the address, the address, the port, the username and password, and then that opens up that connection to the device. That process is exactly what we just saw manually using the SSH and sending that XML back and forth. But hopefully everybody will agree that this is a much friendlier way to connect to a device than sending those manual SSH payloads. Here I'm building the final version of the filter, which simply inserts in Gigabit Ethernet 1 into the filter for interface name. And then I'm going to send a git config. I would like to get configuration details from the running configuration based on that filter. There's a bit of XML processing in here that's going to process the body that comes through, and then we're going to parse it out and print out details. So let's run this example and see what it looks like at its basic side. So Python, NETCONF, example 1. So I send this away. It's going to open up the connection to the device and send our payload. Excellent. All right, so what we've got here is that printed out the raw XML body that came back. And so this is what we actually get back. It's the entire payload that came through. We can see the device gives us back our RPC reply. We can see that it has a data block. And then everything inside of the data block, all of this bit that I just highlighted, is the representation of the interface that I requested. In fact, this is the same interface and the same data that we saw with the RESTCONF request. In this case, though, it's formatted in XML because that's what NETCONF uses. We then process it inside the code, and I'm able to print out the same bit of information that was there, Gigabit Ethernet 1's IP address and net mask. Now, like with RESTCONF, I've got a 1A. 1A is going to look for a loopback interface. The loopback interface, I believe, is the same number, but we'll find out. So no, in this case, it's loopback 102. So we tried to look for loopback 102, but it was not found. The code for example 1A, the only difference is now the interface name is loopback 102. So we tried to find loopback 102. It was not available as it went through. So example 2, what we can see now is how we actually create an interface using NETCONF. Now the basic process is very similar to what we saw with RESTCONF, but instead of creating a payload made out of a JSON-based payload, we have to make an XML-based payload. So I start out with what are the details about my loopback. So its name, its description, its IP address, net mask. And then we have a configuration body. Right here, this configuration body is, again, the representation of that Yang model in XML. In fact, if you compare what I highlighted here to what's still visible in the terminal, they'll look very similar. Because what we're doing is we're building a template for what the device needs to see. Inside the template, I have a placeholder for the interface name, for the description, and then also for the IP address and the net mask. So my template gives me a reusable piece of code that I can use to create any loopback interface that I want. After that, I once again connect to my device, open up that NETCONF connection. I then create the final version of the data by taking the template and then just adding in the details about the loopback interface. Our edit config operation is how we actually send an edit request to the device. So before we sent a git config, now we're sending an edit config. We want to edit the running configuration, and we give it the configuration we want to edit. And then it'll print out the status. With RESTCONF, we printed out status code. With NETCONF, we look for the OK information. So let's run this command. That will be 2. I run NETCONF example 2. So we can see the only output I get here is that RPC status is OK. Similar to RESTCONF, when you create or you edit the configuration on a device, all you get back is a success message, whether it was success or if it failed. And so it says true. If I rerun the 1A, let's see if that loopback 102 now exists. Loopback 102 indeed does exist. We can see here's the data that's there, and it exists. And then we've got loopback 102 in the information. So again, we've been able to, first we asked for details about loopback 102. It didn't exist. We used NETCONF to create the interface and then re-asked for it, and now we can see the interface now exists on the device. Now our final step in this demonstration is going to go through and actually show the delete phase that's out there. So once again, I'm in NetConf example 3 now. In this case, the configuration data is actually very similar to what we saw before. We just don't need as much of the information if all we're trying to do is delete it. We still need to indicate which specific interface we're after, which is why we give it the interface name. And now we're adding in this new piece of information into the payload, this operation equals delete. And this is how with NetConf you indicate what type of operation, what type of edit you're trying to do. The default behavior, if you don't specify an operation, is to create or merge. So it's going to take the payload that you send it and try to apply that to the configuration that's there and make it exist. To delete something, you have to explicitly say, I want to delete this particular object that's out there, which is where this operation delete comes in. The edit config is the same though. We're still editing the configuration. It's just now the config payload is where we actually have the delete information that's out there. Hopefully that follows. And then down here we've got this print. We're going to print out the status that goes in. So currently we have loopback 102. If I go ahead and I now run example 3, this will attempt to delete loopback 102. With luck, we'll get an OK status back, and we did. And we can see OK was true. And so now if I rerun that 1A command, let's go ahead and see if we get our loopback. And now we see no interface loopback 102 found, kind of as we would expect as it goes through. I'm actually doing pretty well on time. I'm going to show one more bit. So one thing that sometimes pops up is we verify these things by using NetConf end-to-end. But let's actually take a look at this and verify it using some CLI at the same time. So I'm going to go ahead and log back into that same CSR. The text is black this time just to keep me straight as to which window I'm in. All right, so now I'm on that same device, and if I do my show IP interface brief, so again, this is our device. We've currently got a gigabit Ethernet 1, 2, and 3 are out there. And so I'm going to go back to the NetConf example, and 1A is how we created loopback 102. So I'm going to run example 1A. I'm sorry, example 2 is how we create, 1A is how we check for it. So here, example 2. All right, so we got an OK status back. So now let's see if we see a loopback 102 on our device. And indeed we do. There's loopback 102, right? Well, also let's go create that interface using the RESTCONF one as well. So I'm just going to change out of the NetConf directory into the REST directory, and we'll run RESTCONF example 2 to create the RESTCONF loopback, which in this case is loopback 101. So we got a 201 back there. If I come back over here and we rerun our show IP interface brief, we can now see that I've got loopbacks 101 and 102. So I've been able to use the device interfaces of both NetConf and RESTCONF at the same time against the same device to create and configure the network interfaces. I'll go ahead and pull them back off. So if I run Python RESTCONF example 3, and again, example 3 is the delete operation. That deletes it. If I check my IP interface brief, we can see loopback 101 is now gone. We don't see it anymore. And if I come back, and we'll do the same thing with NetConf, Python NetConf example 3. All right, we got our true statement back there, and one last check. And again, our interfaces are gone. So we've seen how we've been able to completely manipulate that configuration very effectively to create and recreate those interfaces. With that, we are in pretty good shape. We've got about 10 minutes, so let's do a little bit of question and answer. Do we have any questions that came in?
Hey, Hank, yes. So again, everyone, please submit your questions to the Q&A panel, and I will call those out for Hank. So the first question that came in, and I know that Joseph answered it already, but I figured I'd call it out. Thank you, by the way, Joseph. Guys, Joseph Janitor's on the call. He's part of the NetAcad team as well, so a big thank you to him for answering questions. Hank, do you know how to implement IPv6 with NetDevOps? Is there any framework?
So there's nothing specific about using IPv6 in a net DevOps or an automated fashion than anything else that's out there. And so you'd have to have your IPv6 design in place, understand your addressing information, understand the protocols you're after, all of those pieces. And then you can use any of the different types of programmatic methods that we talk about in NetDevOps for this. And so we dealt with IPv4 addresses in our example today. However, let me see if this device has got IPv6 enabled on it. I don't know if it does. Yep, we can see it here. I don't have any IPv6 addressing on it. But you'll notice here in the output, IETF, IP, IPv6. And so IPv6 addressing can be done in the exact same way. It's just rather than using IPv4 addresses, you'd use the v6. And so there's nothing specific to IPv6 for NetDevOps. It's just a matter of putting that configuration in once you have your good design in place.
Thank you, Hank. And so the next question, and I see that Joseph is actually answering it. And I apologize, what idle do you suggest us to edit Python with? Yep. IDLE?
Yeah, so it's a good question. It's one that pops up a lot. And so idle is typically it's a Python application that comes with Python, and I think I probably have it installed. If I try to do Python-m, I think I can idle maybe. Just idle, okay. Oh, it comes in. I typically don't use idle that comes with Python. I use different IDEs. The one I'm leveraging here in the demonstration today is Atom. Atom is an open source code editor from GitHub, and it's just the one that I happen to be using these days. It works great for Python. Other folks use another tool called VS Code from Microsoft. It's a very popular one these days, pops up a lot. Several folks on my team actually here in DevNet use VS Code. There's also PyCharm. PyCharm is a very powerful Python editing tool that has a lot of extras built into it as they go through. And so the general, I get the question sometimes, which one's the best? Like a lot of things, there is no one best that fits for everybody. I always say the best tool is the one you know how to use. And so if you've got one that's working for you, great. If you're looking for one, or if you want to try some other ones out, I would say the Atom editor, ATOM, from GitHub, or VS Code. Those are two great ones, and they're both open. I know Atom's open source. They're both free, and I think VS Code's open source, but at the very least, it's a free editor that you can take a look at. Those would be two good examples.
Thanks, Hank. And a question from Mario. If he wants to troubleshoot on the fly, what would be the best to use with NETCONF and RESTCONF?
So if you're trying to troubleshoot NETCONF and RESTCONF themselves, I would say troubleshooting and becoming familiar with RESTCONF, because it's a REST API, Postman is always my go-to suggestion to get started with any REST API. For NETCONF, kind of the way that I showed it here, using the Python code in the library, that's this NC client library is a great one to go through. There is a project being developed inside of CISCO that I'm hoping will release soon that will make some of this the NETCONF troubleshooting and operations and getting started a bit simpler, but it's not out yet, so I can't recommend it just yet. So for NETCONF itself, oftentimes when you're first getting started, just working in Python with some simple scripts like this is a great way to get started.
Awesome, great. Prior to iOS XE, was the Yang... Oops. Well, Hank, I just got kicked out.
I think I might have a general idea what the question was. So oftentimes the question comes up is when did NETCONF and RESTCONF and Yang hit the different platforms that are there? In the iOS, so with Catalyst switches and ISR routers, the Model Driven Programmability interfaces started showing up in version 16.3. So they are fairly newer. Those operating systems have been out for a couple of years now. That does mean to use NETCONF or RESTCONF with Yang models, if you've got older switches, so 3750s, even 3750Xs that can't run version 16 code, then you can't use these interfaces on those. You do need to have switches and routers that support at least 16.3, though I highly recommend getting probably up to the 16.6, specifically around RESTCONF that's out there. NETCONF's been out a bit longer. If you're working in the data center space and you've got Nexus switches, Nexus has actually supported NETCONF for a very long time. So odds are good you've probably got NETCONF support that's out there. The models might be a bit different than what you're going to get in some of the newer versions. And then also iOS XR, a lot of the NETCONF and the Yang pieces, it's really started and became very popular in the service provider space before kind of coming down into the data center enterprise. So iOS XR has had robust NETCONF and Yang support for a very long time. I don't even know what version it started, but it's been out there pretty much forever. So you should be able to take advantage of those on those platforms. But with iOS, you are talking 16, let's say 16.6 would be my recommendation as a minimum. If you've got older hardware, you might be challenged on that. However, the CSR, which is available as a virtual device, that's actually what we use in our demos today. You can get a demo version of that very effectively. And we've got all of these equipment up in DevNet Sandbox that you can use anytime you want for free to test out and experiment with these different APIs.
Thanks, Hank. And I know we're coming up to the top of the hour, so I will go ahead and make this the last question. And thanks for answering that on the fly. It just kicked me out. But I'm back. So the last question, and it is a little long, so I did put it in WebEx Teams in case you want to take a look at it. Okay. But could you please tell which are the softwares or online services implementing both RESTCONF and NETCONF stacks via Python or other P1 are useful to execute operations on devices via these displayed APIs?
Okay. I'm trying to, there's a bunch in there and different, depending on exactly what they're after. So I would say online services, and I'm looking at it in WebEx Teams, useful to execute operations via these. All right. So it sounds like the questioner is interested in what tools you can use to make requests and use these interfaces. So I would say, again, the ones that I used in our demos today, so Postman is a great one to interact with devices over RESTCONF. And then once you kind of master the APIs you're after, you can use the requests library inside of Python with RESTCONF very effectively, like we saw. With NETCONF, if you're dealing with Python, NC Client is the best one that's out there. Now, there are plenty of other controllers and tools that are out that leverage these interfaces as well. So if you've got a network management system or you've got a network controller, something like a Cisco DNA Center or Open Daylight, they probably have opportunities to leverage interfaces like NETCONF rather than a CLI interface as well. To know exactly which interfaces or which protocols your different tools support, you kind of have to check the documentation for those. And there's such a wide variety of different network management tools and services, it's hard to say. The one I will comment that comes up a lot with network automation is Ansible. Ansible is used for network automation pretty regularly, and lots of times folks are trying to figure out which protocols to use. Ansible actually supports just about everything. Most of the Ansible modules are still kind of designed to take advantage of CLI interfaces. However, Ansible does have a NETCONF module so that you can send and retrieve NETCONF payloads to program your devices with NETCONF. And Ansible can also send REST API requests, which means you could use it with RESTCONF as well. So that's one that I know a lot of network engineers are interested in. And you can use any of these protocols with Ansible if you'd like to. All right, so you said that was the last. So let me go ahead and close down. I got a couple of final slides here. All right, so we did the questions. So if you're interested in kind of diving deeper into these topics, we kind of just brushed the top of model-driven programmability. I've got links in the slides here, and I know that these will be made available to all the RFCs if you want to go through them, as well as some learning labs. And so we've got learning labs that will let you get hands-on with NETCONF and Yang on iOS, on Nexus, on some XR pieces that are there. And I've been doing NETCONF and Yang and RESTCONF training for quite a while with Cisco and DevNet. And so we've got some other examples of blog posts and videos that you can dive into to get further information. And as always, if you want to stay in touch, please do. You can reach me on Twitter at HFPreston or WebEx Teams at hapresto@cisco.com. Email's the same address. And I encourage everybody to follow Cisco DevNet on all the social medias for the latest in everything programmability that's going on. And with that, I want to thank the audience for sticking around for the talk today and the great questions that came through, and thank NetCat and Kara, the rest of everybody for letting me once again come and talk about programmability with you.
Thank you so much, Hank. Again, the feedback has been great in the chat and the Q&A. It seems everyone really enjoyed the presentation. So thank you so much, Hank, for volunteering your time to come and talk to our students today. So guys, just hang in there, just a few more slides. So Hank talked a lot about Python today. If you're interested, I have set up a course for everyone who is here today and has participated in the DevNet series. It's a free online self-paced course through NetAcad. It's 70 hours. The level is intermediate and no prior knowledge of programming is required. So again, it's a self-paced Python Essentials course. I will share that link in the chat window as well as a link to the DevNet community. We really encourage y'all to go check out all of the free resources that are available at the DevNet community. There's a lot of great content there. So again, both of those will go in the chat window in just a second. And again, the next DevNet session is on April 17th. It is before, during, and after a security attack. And I did already put that link in the chat window, so y'all can go copy and paste it and register for that today. So we hope to see you on April 17th, same time as today's webinar started at 9 a.m. Pacific Daylight Time. So with that, just a huge thank you to Hank again for a wonderful presentation, and a big thank you to Joseph for joining us to answer questions in the chat window. So again, thank you to both of you, and thank you to everyone for coming and joining us and giving us an hour of your time. So I hope everyone has a wonderful rest of the morning or afternoon or evening, and we will talk to you on April 17th. Thanks, everyone.